ultimate route to JEE success with JEE Test Prep app by Extramarks, adaptive testing platform, India's top faculty, micro-scheduling, live and recorded sessions, doubt-solving sessions, national level weekly tests, analytics and reports. Download the app now.
Hello students, this is Dhana Kumar. Today I am going to discuss about geometric progression. In last session we discussed arithmetic progression and their properties. Now I will explain geometric progression. What is mean by geometric progression and with some examples and properties of geometric progression. Let us see. So first, introduction of geometric progression. Next, nth term, sum of n terms and properties of geometric progression. So what is meant by geometric progression? A sequence of non-zero numbers a1, a2, a3, so on an is said to be geometric progression if the ratio of each term except the first term and the term preceding to it is always constant. Is always constant means what? Geometric progression is a sequence of numbers whose first term is non-zero and each of the succeeding terms is equal to the preceding term multiplied by a constant. Thus, in a GP, the ratio of successive terms is constant. This common factor is called common ratio of the series. Now, let us say some simple example. For example, I am taking like this 1, 2, 4, 8, 16, enough, 5 terms I took. Now you check it, these terms are in GP or not. How to check it? In earlier session, I explained arithmetic progression. Arithmetic progression condition, what I told? Second term minus first term is equal to third term minus second term is equal to fourth term minus third term, means differences are same. Now here GP, how to check it? You calculate ratio. Now you observe this one. Second term by first term. Here second term is what? 2. 2 by 1. 2 by 1. Answer is what? 2. In the same way, you check it third term by second term. Here third term is 4. 4 by 2. 4 by 2 is what? 2. And similarly, you take next 8 by 4. 8 by 4 is 2. 16 by 8 is 2. Means ratios same. If ratios is same, then we can say that given problem is in GP. And this ratio is called common ratio. Common ratio of the GP. Right. And it is generally denoted with ratio. Starting letter is R. So common ratio is generally denoted with the small letter R. And here one is called first term. In general, first term is denoted with A I am taking. Now, you observe this one. I am taking general terms of GP. First I am taking A. Next term will be multiply first term with common ratio. I am taking common ratio as R. Then second term will be what? A into R. So AR. Next term AR into R. R into R is R square. So third term will be a r square. Next term will be a r cube. A r cube and so on. Right. So any term in GP is equal to preceding term into common ratio. Right. Now let us see one more example. You see here 4, 8, 16, 32 is a GP. Why? See here 8 by 4 answer is 2. 16 by 8 answer is again 2. 32 by 16 again answer is 2. Means common ratio is what? 2. Ratios is same. Therefore this example is there in GP with first term. Here first term is 4 and common ratio is 2. Right. Now let us see next nth term of GP. Nth term of GP. Here I am taking A is the first term and R is the common ratio of the GP. Right. Then what we wrote? First term A, second term AR, third term AR square and fourth term AR cube. Now just you observe this one simple point. First term denoted with T1. First term is what? A. For our convenience, I am writing A is, for our convenience, I am writing A can be written as A into R power 0. Right? Then T2, actually T2 means second term. Here second term is AR. Okay. Second term is AR. And third term is what? AR square. See? Third term is equal to AR square. So on. Enough. Now, what about nth term? Using these three values, you observe this one. In every term, A is same. So in nth term also, A you write down. Next, base is what? R. Here also write base is R. Then R power value, you observe this one. First term R power 0. Second term R power 1. Third term R power 2. Means R power value is that term number minus 1. Term number minus 1. So nth term will be what? R power term number n minus 1. So general term, generally nth term considered as general term. So general term mean AP is Tn is equal to AR power n minus 1. A into R power n minus 1. Right. Let us coming to one simple example. The third term of geometric progression is 4. Right. Here you see third term. Third term is what? AR square. Okay. So here I am writing AR square is equal to 4. AR square is equal to 4 I am writing. Then find the product of first 5 terms. Product of first 5 terms. Right. Okay. First term is what? A into second term is AR into third term is AR square and fourth term is AR cube and fifth term is AR power 4. Now simplification, you observe this one. A into so on. A is repeated 5 times. So this value can be written as A power 5. Next, R into R square into R cube into R power 4. See here, bases are same, so power should be added using that formula x power m into x power n. So formula will be x power m plus n. So r power value will be here r power 1 plus 2 plus 3 plus 4. So 4 plus 3 is 7, 7 plus 2 9, 9 plus 1 is 10. So r power value is 10. That is equal to, so a power 5 into r power 10 you write in terms of given condition. What is that given condition? A r square. So for our convenience, this value can be written as a into r square whole power 5, right? R square power 5, 2 5s are 10, so r power 10 only, and a power 5 satisfies. So a r square value is what? 4. So answer is 4 power 5, right? So the product of first 5 terms is equal to, answer is 4 power 5, right? Let us coming to next one, sum of n terms. Sum of n terms. See here, same as usual, I am taking first term is a and common ratio is r. Actually general series is what? a r square and next third term is a r square plus so on a r power n minus 1, because we are calculating sum of n terms. So I am writing only n term. Generally sum starting letter s, n terms, so it is denoted with sn. It is denoted with sn, right? So sum of all these n terms, formula is a into r power n minus 1 by r minus 1 formula, where r is not equal to 1. Why I am taking especially r not equal to 1 this formula? If r is equal to 1, what happened? If you are substituting r is equal to 1, 1 power n, 1 minus 1, 0, by 1 minus 1, 0. It is in the form of 0 by 0. 0 by 0 is not determined, indeterminate. So that is why I am writing r is not equal to 1. If r is equal to 1, then how to find sum of n term? At that time you take actual series, this one. Here you put r is equal to 1. Then answer will be a plus so on a n time. So then answer will be what? N into a. So if r is equal to 1, write na. R not equal to 1, at that time you have to use this formula. Let us coming to one example. Find the sum of 10 terms of the GP 5, 15, 45, so on, right? So sum of n terms in GP, first you check it, right? Here first term is 5. Next to find common ratio. Common ratio, how to find? Second term by first term. 15 by 5. Answer is 3. A common ratio not equal to 1. So at that time you have to use this first formula only. And n means number of terms. N means number of terms. Here we are calculating sum of 10 terms. So n is equal to 10. Substitute these three form values in this formula. Then answer will be what? You see, a means 5 into r power, r is common ratio, power n, number of terms is 10, minus 1 by 3 minus 1. 3 minus 1 value is 2. then find 3 power 10 general simplification minus 1. That answer will be 59,048. Then general calculation 2 cancellation possible. That answer is this. Into 5 write down, answer will be 1,47,620. This is the procedure for finding sum of n terms. Sum of n terms. Then coming to properties. Now in AP we discuss some properties. In the same way, GP also some properties are there. What is that first property you see? If 3 terms A, B, C are in GP, 3 terms A, B, C are in GP, then condition is what? In GP, general condition is what? Ratios same. So that is second term by first term, B by A is equal to third term by second term, C by B. Then cross multiplication, B into B, B square is equal to AC. So if 3 numbers A, B, C are in GP, while solving questions, A, B, C are in GP is there, immediately use B square is equal to A into C condition, right? Then here B is called geometric mean of A and C, right? Next, second property, observe this one. If each term of a GP is multiplied or divided by some fixed non-zero number, then the resulting sequence also in GP, right? See, let us see one example. Here I am writing, say for example, 5 values I am taking simple way. 1, I am taking 1, next 2, next 4, next 8, next 16, enough. See, this example it is there in GP or not, you observe this one. 2 by 1, 2, 4 by 2, 2, 8 by 4, 2, 16 by 8, 2. It is in ratios same, so it is in GP. What about the meaning of this second property? If each term of a GP is multiplied or divided by some fixed non-zero. Okay, multiplication I am taking with some fixed non-zero number. Let us see, I am taking number, simple example, I am taking number is 2, fixed number. Multiply each and every element with number 2, right? So observe this one, what happens? 2 ones are 2. Okay, here I am writing 2. Next 2 twos are 4. Next 2 fours are 8. Next 2 eights are 16. Next 16 into 2, 32. 2, 4, 8, 16, 32 we got. Now you observe this one, resulting sequence, that is this answer, it is in GP or not. See here, second element by first element, 4 by 2, answer is 2. 8 by 4, again answer is 2. 16 by 8, again answer is 2. 32 by 16, answer is 2. So ratios same. Ratio same means it is in GP. That is the meaning of the property. So in GP, multiply or divided with some fixed non-zero number, then resulting sequence is also in GP. Then let us coming to next property. If A1, A2, A3 so on one sequence, B1, B2, B3 so on another sequence, both are GPs, then product of the corresponding terms A1 into B1, A2 into B2, A3 into B3 are division First term, here first term you take A1 by B1, A2 by B2 are also in GP, are also in GP. Now let us coming to next one. See, one more important property. If A1, A2, A3 so on is a GP of positive terms, then log of these values, log A1, log A2, log A3 so on is in AP. Why? Observe this one simple example. General, see, already we wrote at the time of introduction of GP, we wrote general series. What is that general series of AP we wrote? First A, observe this one, A. Next term is AR. Next term AR square, AR cube, enough, so on. It is in GP. Right? Now you take log, apply this one, log of every term you see here. First term take log of A. Next, log A into R. In logarithms, one property is the log AB. Log AB, formula for what? Log A plus log B. So this can be written as log A plus log R. So here what is the property we use? Here I am writing that property, log A plus log B is equal to log AB. This format is there. I wrote this one. And second one more property also we will use, that is log x power m. Log x power m formula is m into log x, right? Okay, let us coming to next term, log a into r square. A into b form is there, you write this condition, so that is log a plus log r square, comma, so on. Okay, now observe this one, it is in the form of log x power m. Log x power m, what we wrote formula, m log x, that is this power you write outside of the log, then automatically this value will be what? Okay, one more step, this log a as it is I am writing, comma, next log a plus log r, comma, log a plus 2 times log r, and so on. Now observe this one, second term minus first term, log a cancel, third term minus second term, log a cancel, 2 log r minus log r, 2 log r minus log r, answer will be what? Log r. So here you observe that one, differences is same, right? Differences same, it is in arithmetic progression. That is the meaning of the property. If given problem, given sequence is in GP, then log of those corresponding terms, answer will be, it is there in arithmetic progression, right? Let us coming to next property. In GP, in AP I explain, while solving questions, sum of 3 numbers is there. At that time, instead of taking A plus D, A plus 2D, one format I told. In the same way, GP also is there. But in GP, while solving questions, you observe that one in given problem, product of the terms is there, product of 3 terms, or product of 4 terms, product of 5 terms, product is there, generally GP sequence will be what? AR square, AR cube, so on. Instead of taking these values, if product is there, if you are taking these values, in first step only, we can find out one unknown value. Calculations are easy. Suppose product is not mentioned, at that time you take this only, AR square, AR, right? Now observe this one. 3 terms are there or 4 terms are there. How to select it? Instead of by hearting one order, you see. First I am writing A as it is. R is common ratio. Left side division operation applied. Right side multiplication operation I am applying. That is A by R. Here I am writing A by R. Right side multiplication operation, A into R. Again divide with R left side, A by R square. Here multiply with R right side, A R square. Next here A by R cube. Here A R cube, and so on. Enough. Odd number of terms is there including A, write down. Even number of terms is there excluding A, write down. Okay, suppose 3 numbers in GP can be taken as 3 is odd number. Odd number means what I told, including A. So 1 term is A. Next, how many terms we want remaining? 2 terms we want. 1 left side, 1 right side you take. That is A by R, AR. See here, same thing we wrote. A by R, AR. Suppose 5 terms in GP is there, then including A, 1 term is A. Remaining 4 terms we want. 2 left side, 2 right side. A by R square, A by R, AR square. In this way you have to select it. Suppose 4 terms in GP, even number of terms is there excluding A, and alternate terms you consider. That is A by R cube. Next you remove this one, A by R. Next AR. Next AR cube. See here, A by R cube, A by R, AR cube. So this presentation is useful if product of the terms involved in the problem, right? If product is not there in question, then you take the terms should be AR square, so on. Next session I will explain some another topic, right? Thank you.
For more such videos, please like, share and subscribe to Extramarks Test Prep YouTube channel.